Example 1, factor. In part A, we see that we have 4 terms, but we can't use a grouping strategy that we used before to factor. We have to come up with a new one. So this new strategy involves identifying the 3 terms that make up a perfect square trinomial, and then we start by factoring that perfect square trinomial. So in part A, the first 3 terms actually make up a perfect square trinomial. Remember, for a perfect square trinomial, you do need to have one term that has a variable squared in it, another term which has the variable that is raised to an implied exponent of 1, and then a constant. And then the square roots of those outside terms, when multiplied and doubled, have to equal to the middle term. So if I look at the first 3 terms here, the square root of x is x, the square root of 9 is 3, 3 times x is 3x, when doubled gives me 6x. So here we clearly have a perfect square trinomial. Factoring in the perfect square trinomial involves taking the square roots of the outside terms and the sign of the middle term. So the factored form would be x minus 3 squared, because we end up with 2 identical factors, which we can write in this form. Okay, and then following that factored form, we still have minus 4y squared. So after we factor the perfect square trinomial, what we essentially end up with is now a difference of squares. It's a difference of squares that is a little bit more complicated than what you're used to seeing, but it is in fact a difference of squares. We have 2 terms here separated by subtraction, and we can take the square roots of each term in order to factor. So that's what we're going to do. The square root of x minus 3 squared is just x minus 3, because the square root undoes the squaring. So we have x minus 3. And then the square root of 4y squared would be 2y. You would have to take the square root of 4, and you would have to take the square root of y. So these 2 terms will appear in each bracket. And then, since it's a difference of squares, the 2 terms will be separated by addition in one bracket and subtraction in the next bracket. So this is the factored form of the original expression that we were given. Let's look at another example here. Here we have 36b squared minus a squared minus 16 minus 8a. So we have to determine which 3 terms make up our perfect square trinomial. So we see here that we have a squared term, and we have another term that contains a, so we must use those 2 because they have the same variables, and we must use this constant. So I'm going to first rewrite this in descending degree order so that the constant appears last and the a squared term appears first. Now I'm going to factor. Now, if I'm factoring negative a squared minus 8a minus 16, I have to remove a common factor of negative 1 first. Remember, when the first term in your expression starts with a negative, you have to remove that common factor of negative 1. And after dividing all 3 terms by negative 1, I'll be left with a squared plus 8a plus 16. Next step is to factor this perfect square trinomial. So I'm going to take the square roots of the outside terms and sign of the middle. Square root of a squared is a, square root of 16 is 4, and then sign of the middle term is an addition sign, and the 2 factors will be identical, so I'm going to put a squared there. Now the ones implied, you can leave it out. This is a difference of squares. So now I take the square roots of each of these terms. Square root of 36b squared would give me 6b, because the square root of 36 is 6, and the square root of b squared is b. Square root of a plus 4 squared is a plus 4. And I'm going to put it in brackets here. So these are the 2 terms that will appear in the first factor and the second factor. And the terms will be separated by addition in the first bracket and subtraction in the second bracket. Now the reason I put a plus 4 in brackets is because when we have subtraction in the brackets, we have to remember to not only subtract the a, but the 4 as well. So we can simplify this a little bit further. The first bracket would just have 6b plus a plus 4. The second bracket would have 6b minus a minus 4 because we're subtracting each of these terms that are following the subtraction sign. So remember to reverse the signs of the terms that follow the subtraction. So this would be our final answer in this case.